Just before we start, a quick shout out to Squarespace for sponsoring today's video. We've been searching for signs of extraterrestrial life for over 100 years, and so far we've found no evidence of anything beyond our planet. Out of all the billions of stars just in our own galaxy, the Milky Way, with all the billions of associated planets, let alone the billions of galaxies in the rest of the universe, we haven't seen or heard of anything that we would consider as proof of intelligence. But what are we searching for, and how are we searching for it? We are framed by our own human expectations, our current technology and understanding of the universe, and the physics that we believe make it up. In other words, we're looking for what we might expect to see based on our own current situation. If beings are using more advanced technologies, we might never find them. A bit like showing a Victorian a smartphone. Only 120 years difference, but a world away in technology. So let's look at what we've done to try and find proof of intelligent life beyond planet Earth. Before we go any further, we have to preface this with a couple of assumptions. Firstly, that there is intelligent life out there, because if there ain't, then it seems to be an awful waste of space, to quote Carl Sagan's Contact. Secondly, what intelligent life out there has reached a point where they can broadcast their existence beyond the confines of our own planet by radio, be that intentionally or as a byproduct of communications amongst themselves. Also, that any intelligent beings are active at the same time as us. If they reached the same ability to transmit using radio as we have now, even as little as 1,000 years ago, an infinitesimally small difference in cosmic terms, we would have missed them. Just look at how our own politics and attitudes flip-flop almost year to year. Maybe they decided to keep radio silent after a time, or have moved on to tech that we don't yet know about. Sounds obvious, but don't forget that it was just at the turn of the 20th century, 120 years ago, that we learned how to send signals by radio, and these were only meant to be received by other humans. Ever since, we've been leaking radio waves into space, from the most basic spark transmissions of Marconi's first tests to high-speed data communications with satellites and space probes of today, and everything else in between. By now, these signals will have reached over 1,000 nearby stars. And if there were intelligent life in this area, they could have picked it up, deciphered it, and sent us back a reply, providing that after seeing our TV content, they hadn't deemed us too mad, bad, and dangerous to know. Back in 1877, Italian astronomer Giovanni Schiaparelli, while studying Mars, saw features which he called canali, or lines, connecting darker patches on the surface that would change with the seasons. The word canali was mistranslated into English as canals, and soon people began to think that these canals were an irrigation system linking the darker areas, which might be lakes and vegetation, built by the Martians to irrigate the planet's surface. In 1896, Nikola Tesla thought that an extreme version of his wireless electrical transmission system could be used to contact these intelligent beings. Even though the canals of Mars were later proven to be an optical illusion, the thought that Mars could be a world like Earth populated by intelligent beings took off and was boosted by one of the first sci-fi novels, H.G. Wells' War of the Worlds. This portrayed the Martians as an alien species coming to colonize and take over Earth, which some believe to be a play on our own colonization of the New World and its more primitive peoples. This trope has been with us ever since, and has led to some to advocate not sending out signals to potentially hostile ETs, but it did begin the search for signs of life outside our own planet. In 1899, Tesla thought he'd picked up odd, repetitive static signals which seemed to cut off when Mars was setting in the night sky. Later analysis of his data pointed to possibly picking up Marconi's early transmissions, or even naturally occurring noise from Jupiter's moon Io as it moved through the magnetosphere of Jupiter. In the early 1900s, Tesla, Marconi and Lord Kelvin thought that radio could be used to contact Mars, and Marconi said that he thought he'd picked up Martian signals on his equipment. On August 21st of 23rd, 1924, Mars came closer to Earth than at any time in the previous century or in the next 80 years. In the US, a 36-hour period of radio silence was promoted for 5 minutes on the hour every hour. During this time, the United States Naval Observatory used an airship to lift a receiver to 3,000 meters to listen to signals coming from Mars and try and translate anything which they received, but of course nothing was picked up. In 1959, Giuseppe Cocconi and Philip Morrison wrote a paper proposing searching the microwave spectrum centered around the hydrogen line at 21 centimeters or 1.42 gigahertz for signals. Cocconi wrote, "The probability of success is difficult to estimate, but if we never search, the chance of success is zero." The reason for using the hydrogen line is around this wavelength signals pass through cosmic dust and gas clouds much better than visible light, as well as our atmosphere, and the universal nature of hydrogen would make it the best place to send and receive modulated signals over the vast distances of space. Using microwaves for communications also means that the antenna used are small because they are a product of the wavelength. 1.42 gigahertz is just 21 centimeters, so spacecraft can use small antennas. In 1960, Frank Drake, later of the Drake equation, a probabilistic argument used to estimate the number of active communicative extraterrestrial civilizations in our own galaxy, started SETI, or the Search for Extraterrestrial Intelligence, with Project OSMA, using the 26-meter National Radio Astronomy Observatory in Greenbank, West Virginia. Drake scanned a 400 kHz band around the marker frequency using a single-channel receiver, but found nothing of interest. This also highlighted the problem that they were only able to analyse a tiny fraction of the frequencies in a tiny fraction of the sky. In 1965, John D. Krause at the Ohio State University Radio Observatory created the Big Ear, a flat reflector in a remote location to search for extraterrestrial radio transmissions. Big Ear was the first to be used to map the sky for radio sources from 1965 to 1971. In 1971, NASA funded a SETI study including Frank Drake, but concluded with a proposal for Project Cyclops. This was a suggested Earth-based radio telescope array with 1,500 dishes, but with a price tag of $10 billion. Needless to say, it wasn't built, but it laid the groundwork for modern SETI works moving forward. In 1977, Big Ear detected what is now known as the WOW signal, the first signal that looked like it could have been sent by an artificial source. Many people have misinterpreted the character string 6EQUJ5 highlighted on the printout as an encoded signal, but this is just a method of showing the signal strength. The numbers 1 to 9 indicate a signal-to-noise ratio strength compared to the average background noise measured a few minutes earlier. So the number 3 would be a signal 3 times the average background noise. For higher signal intensities, the letters A to Z are used, A being 10 to 11, B being 12 to 13, C being 14 to 15, and so on. The letter U equals 30 to 31, or 30 to 31 times that of the background noise. The signal was an unmodulated continuous wave, although any modulation with a period of less than 10 seconds or longer than 72 seconds wouldn't have been detectable. That was 46 years ago, and although the patch of sky around Sagittarius where the signal was picked up has been checked many times, nothing like it has been found since. Over the years, there have been many theories about the WOW signal and that it could have been created by a star or a comet. There were 2 comets passing through that area of the sky at the time, and the signal was blue shifted, indicating it was travelling towards Earth at about 10 kilometers per second. However, the comet theory has since been discredited because they produce a much broader spectral content, amongst other things. The main problem with trying to detect a signal is that you don't know when it could be coming, where in the sky, and on what frequency. This is assuming that it's been sent by a radio and not some other form of technology like laser or maser, or other technology which we do not yet know about. Maybe using radio to other intelligent beings out there is like us trying to receive an email with 2 cans and a piece of string. But until we know better, we have to scan as much of the sky as possible for as long as possible and on as many likely radio frequencies as possible. When we scan the sky for artificial signals, it's like tuning a radio to find a station. Normally you start at one end of a scale, turning the dial and listening for something of interest. But instead of listening for stations, astronomers are looking for signals from space that are not naturally occurring things, like noise, quasars, pulsars, and other things like that, but signals which could have been made by intelligent beings. This is how they used to look for signals, slowly scanning through the frequencies, but this is very slow when you need to scan a range of frequencies that could be millions of times greater than the AM or FM band on a domestic radio. To speed up the process, astronomers use a spectrum analyzer, which allows you to see a range of frequencies, or a spectrum, all in one go. Using modern digital signal processing and fast Fourier analysis, a spectrum covering millions of frequencies can be scanned in one go, greatly speeding up the process to find a signal with the right kind of characteristics. In 1980, when Carl Sagan, Bruce Murray and Louis Friedman founded the US Planetary Society to carry on SETI work, there were only analog spectrum analyzers available. These had a limited number of frequency filter channels which greatly limited the search. By the early 1980s, and with the advancement in digital electronics and digital signal processing, it was possible to build a portable analyzer with 131,000 channels called the suitcase SETI for Project Sentinel, and used the 26-meter Harvard-Smithsonian radio telescope at the Oak Ridge Observatory, Harvard in Massachusetts. By 1985, this had been replaced by META, or the Mega Channel Extra Terrestrial Assay, which could scan 8.4 million channels and used frequency Doppler shift to distinguish between signals coming from Earth and those from space. In 1995, META was replaced by BETA, or the Billion Channel Extraterrestrial Assay, which could receive 250 million simultaneous channels with a 0.5 Hz resolution per channel from 1.4 GHz to 1.720 GHz. A new feature of BETA was the rapid and automatic reobservation of any candidate signals. On March 23, 1999, the telescope that Sentinel, META and BETA had used was blown over in strong winds and severely damaged, forcing the closure of BETA. Since then, our processing ability has increased exponentially, and dedicated arrays have been set up to scan the skies like the Allen Telescope Array, or the ATA, named after the project's main benefactor and Microsoft co-founder Paul Allen. This was meant to be like a mini Cyclops array, but with 350 6-meter dishes with offset Gregorian design and advanced design features, which could instantaneously image an area of the sky 17 times larger than that obtainable by the Very Large Array telescope in New Mexico, which has been featured in several movies, including 1997 Contact. Using many more smaller antennae, it's able to gather many times the data compared to traditional large dish telescopes of comparable size. The issue in the past was that all the separate signals had to be combined, which was not commercially viable until the advent of low-cost, high-power computing. So far, just 42 of the 350 dishes have been built, but most of the hard work and development has been done, and the rest of the 308 dishes were estimated to cost $42 million in 2007, about half the price of a traditional telescope array using large dishes of a similar collection area. From 2007 until 2015, the ATA has been searching for 12 hours a day, 7 days a week, and found hundreds of millions of technological signals. However, all have been put down to Earth-based interference, noise, or too short a duration, less than 1 hour, to be classified. In 2015, the ATA was used to investigate Tabby's star with its unusual light fluctuations of up to 22%, which some thought could be evidence of a Dyson sphere. And in 2017, the interstellar asteroid Oumuamua was investigated for signs of technology, but no unusual radio emissions were found on either occasion. If the ATA were to be finished, it would be one of the largest and fastest radio telescopes in the world. And this also highlights the problem of funding is still very difficult to find for SETI projects, even when companies like Mark Zuckerberg's Meta can spend $10 billion on a VR world where legs on the avatar seem to have been an afterthought, and Elon Musk can spend $44 billion to buy Twitter when it was valued at a quarter of the price, and every scientist and his dog is begging for government research grants. Telescope time is very limited, and too many scientists are chasing too few time slots. Searching for signals from extraterrestrial sources, be they intentionally sent or not, requires dedicated telescopes like the ATA array, searching for as close as 24/7, 365 days a year, because you never know when these signals could arrive, and like the WOW signal in 1977, could arrive and never appear again. Piggybacking onto the largest radio telescopes like the VLA in New Mexico, or the Arecibo Observatory when it's up and running again, or the 500-metre FAST newly built in China when there is a bit of free time, may be better than nothing, but it's far from the best solution. There are other SETI-like projects around the world, but compared to mainstream science, the importance we place on searching for intelligent life out in space, which could be the biggest discovery in history, makes you wonder if we should be looking for intelligent life on this planet before looking elsewhere. Now, you may not be looking for ET, but Squarespace can undoubtedly give you a deal that is out of this world for hosting and building your next website or upgrading your existing one. With Squarespace, you can quickly have a great-looking website to grow your blog, business, or online presence. With their powerful included blogging tools, you can create your own blog and use them to categorize, schedule, and share posts and build interaction with their fully integrated commenting system. You can connect with your audience members and generate revenue through gated members-only content, manage your members, send email, communications, and connect with your social media account to push website content to them and spread the word via your followers, all in one easy-to-use platform. If you have an online store, they have new third-party tools to help you manage inventory, promote products, track sales, and handle tax and shipping around the globe. All you need to do to get started is to go to squarespace.com for a free trial. Then, when you're ready to launch, go to squarespace.com/CuriousDroid to save 10% off of your first purchase of a website or domain.